Welcome to EDU World Space.
In this question, we'll understand the basic concepts of the wave motion. So the question is, there is an aluminium wire of length 60 centimeters and it is joined to a steel wire of length 80 centimeters, right? The tension produced is 40 newtons and the cross-sectional area of both the wires are given. We have to find the minimum frequency of a turning fork which can produce standing waves in the system with the joint as a node, right? The mass densities of the aluminium and the steel are given. So rho s is 7.8 grams per centimeter square cube, and for aluminium it is 2.6. So we can find the mass of the steel wire as well as the mass of the aluminium wire per unit length. So 7.8 into 10 raised to power minus 2 will give mass per unit length. Right, so a node is always placed in the joint, and since aluminium and steel rod has same mass per unit length, the velocity of the wave in both of them is same. So we can find the velocity of the wave, that would be equal to square root of t by m, that is t is the tension, and we can substitute the value of the tension, that is 40 newtons, divided by the mass per unit length is same for both the wires. So this would be equal to 500 by 7. For minimum frequency, there would be maximum wavelength. For maximum wavelength, the minimum number of loops to be produced, right? So the maximum distance of a loop is 20 centimeters. So the wavelength would be equal to 2 multiplied by 20, that is 40 centimeters, or we can say 0.4 meters. So the frequency would be equal to V by lambda, that is 500 by 7 divided by 0.4, that would be equal to 180 Hz, right?